In this video, we will be discussing conversion of non-deterministic finite automata, that is NFA, to DFA. Whenever we talk about conversion of NFA to DFA, we have two methods. One is using Thompson's and subset, which we discussed in the earlier slides, and second is direct method. In the coming slides, we will be considering the second method. Say for example, I have a NFA given below and I want to generate a DFA for this. Initially, I'll draw the table. I have sigma as AB and I have three inputs, Q0, Q1 and Q2. Q0 is the start state and Q2 is the final state. Now corresponding to Q0 and A, I want to get the entry in the table. Q0 on A gives Q1 and Q2. So Q0 on A would be Q1, Q2. Then I have Q0 on B. When I check Q0 on B, there is a self loop on B. So I have Q0 on B is Q0. Then I move to second one, Q1 on A. Q1 on A is a self loop of Q1. So input is Q1. Then Q1 on B. This gives me Q2. Then I have Q2 on A, which is a self loop, gives me Q2. And Q2 on B gives me Q2 itself. Now, just by going through this table, I see that I have one new combined state, that is Q1, Q2. So I'll put that Q1, Q2 as a single combined state in the table, and I will consider this as a new state, that is the fourth state. Now I will find Q1, Q2 on A. That means Q1, Q2 on A is Q1, Q2 itself. So I'll write Q1, Q2. Q1, Q2 on B is only Q2. Now since more new states have been generated, so that means I have converted my initial NFA into a DFA. Just see this. I draw the DFA corresponding to the table which has been generated. Here I have four states, Q1, Q2. The new state which was generated is treated as a single state. Now, since Q1, Q2 has final state of initial NFA, which was Q2, so this state, Q1, Q2, the new combined state will also be the final state. So this is how I convert my NFA into DFA. Once I have converted this, next important point is I need to check whether there is any redundant state. Just see this. In this Q1 state is one in which there is no in move from any other state. It has just two out moves. One is corresponding to B and another is corresponding to A. Since this state has no in move, this can be removed as it is a redundant state. So my final output corresponding to NFA is this. So I have three state DFA which is generated corresponding to the initial input which I had. Let's consider another question. In this we have four states. Again, based upon the similar patterns as we discussed in question 1, we will draw a table. Table will have four states. Sigma is AB, Q0 is start state and Q3 is final state. So we start with Q0 on A, we get Q1, Q2. So we'll put Q1, Q2 in it. Next we move to Q0 on B. Q0 on B gives nothing. So we have a 5 state. Then we move to Q1 on A. Q1 on A moves to Q2. So we put Q2. Q1 on B gives us two states. One is Q1, another is Q3. So we put Q1, Q3. Next we have Q2 on A. Q2 on A gives us Q2 itself along with Q3. So we have a clubbed state Q2, Q3, and Q2 on B gives us only a self loop. So we have Q2. Next we move to Q3. Q3 on A. Q3 on A gives us 5 because we don't have any out move. And Q3 on B gives us Q2. So ultimately, we get entire table corresponding to the initial NFA. Now, if we see this table, we will identify that we have three new states. One is Q1, Q2, another is Q1, Q3, and the third one is Q2, Q3, which is being generated. We will add all these three states in the table in the form of three new clubbed state with three new rows. Now we will consider Q1, Q2 on A. We get Q2 union Q2, Q3, which is equivalent to Q2, Q3. Then we have Q1, Q2 on B, which is Q1, Q2, Q3. So we have a new clubbed state, which has three states Q1, Q2, Q3. Then we move to Q1, Q3 on A. Q1, Q3 on A gives Q2 only. Q1, Q3 on B. This gives us Q1, Q2, Q3. Then we have Q2, Q3 on A. This gives us Q2, Q3 itself. And the last one is Q2, Q3 on B. This gives us Q2. Since we have one more new states, Q1, Q2, Q3, we will add this clubbed state as a single state and it will be added into the table. And now we will try to identify the entries corresponding to Q1, Q2, Q3 on A and B. Q1, Q2, Q3 on A. This gives us Q2 union Q2, Q3, which is Q2, Q3. Q1, Q2, Q3 on B. This gives us Q1, Q2, Q3. So after doing this, we find that now no new state is generated. So that means we have ultimately achieved the DFA table and now we can draw it. Before doing that, we need to consider which all states will be considered as final states. Since initial NFA had Q3 as final state, all the clubbed states which will have Q3 will be considered as final states. We have three states Q1, Q3, Q2, Q3 and Q1, Q2, Q3 which have state Q3. So all these will be the final states. So in turn we will have four final states. Now we will draw the DFA corresponding to the table given on the right hand side, and the DFA which we get is this. Once we have drawn the DFA, we are left only with the one step, and that step is to find whether there is any redundant state. If there is any redundant state, we should remove it. Just see state Q1. We have two out moves, one to Q2, another to Q1, Q2, but we don't have any in move. So this can be comfortably removed. Second state which can be removed is Q3 because it has only single out move. And then we identify that we have Q1 and Q3 as redundant, which have been removed. And ultimately, we get the final output. This is how we have generated the final DFA. Now, if we summarize this entire thing, we can say that we have generated the DFA from the NFA using a direct method in which we have drawn the table and then we have generated the DFA. And in the coming slides, we will be discussing about minimization of DFA.